So now we will study what is the difference between a sequence and an arithmetic progression. We will study what is the difference between a sequence and an arithmetic progression. So let us begin it. What is an AP, or you say what is an arithmetic progression? Very simple definition of it. A sequence in which two consecutive terms differ by a common number. What is an AP? An AP is also a sequence in which two consecutive terms differ by a common number. For example, 2, 4, 6, 8, 10, and so on. This is also a sequence. So what is the difference between these two consecutive terms? It is 2. What is the difference between these two consecutive terms? It is also 2. What is the difference between these two consecutive terms? It is also 2. What is the difference between these two consecutive terms? It is also 2. So the sequence is 2n, and this is an AP. This is an AP. But when we take another example like 1, 4, 9, 16, 25, and so on. What is the difference between these two terms? This is 3. What is the difference between these two terms? This is 5. These two, this is 7. These two, this is 9. So the general term of this sequence is n square. This is also a sequence. This is also a sequence. But when you see this second sequence, this is not an AP. And why this is not an AP? Because the consecutive terms do not differ by a common number. Look at these two sequences. What is the definition of arithmetic progression? A sequence in which two consecutive terms differ by a common number. So this is a sequence 2, 4, 6, 8, 10. This is also a sequence 1, 4, 9, 16, 25. This is also a sequence. Both are a sequence. Now let us check whether both are an AP or not. So what is the general term of the sequence? This is 2n. What is the general term of the second sequence? This is n square. What is the difference between two consecutive terms of the first sequence? This is 2. All the consecutive terms differ by a number 2. But when you look at the second sequence, the first term differ by 3. The first two consecutive terms differ by 3. The second and the third term differ by 5. This third and the fourth by 7. And the next that is 9. So this is the difference. In this, the consecutive terms do not differ by a common number. The number is changing again and again. So this is not a sequence. This is a sequence, but this is not an AP. So this is the difference. Now, how to know from the general term that a given general term of any sequence will give an AP or not? How to know? How to know that whether a given sequence, general term of any sequence will produce an AP or not? This is the point to study. But before we move into it, let us see what is the generalized sequence of any AP. So the generalized sequence of any AP is, let the first term be A and let the second term be A plus D. And what is D here? D here is the common difference. And let the third term be A plus 2D. The fourth term be A plus 3D, the fifth term be A plus 4D, and so on. So the first term of any AP is, first term of any AP is A, The common difference. What is the common difference of any AP? The common difference of any AP is D. And the generalized structure of any AP is A plus D, A plus 2D, A plus 3D and A plus 4D. This is the generalized form of any AP where the first term is A and the common difference of D. We have understood how to see whether a given sequence is an AP or not. Now let us look at from the general term whether a given sequence is an AP or not. But before we go into it, let us study a formula. The formula is common difference of any AP equals to an plus 1 minus an. If an plus 1, what does an plus 1 means? It means the successive term. What does an plus 1 means? The successive term. I will give you a very simple example. Let us take an arithmetic progression. 1, 3, 5, 7, 9, 11, 13. So this is an AP. You know all the numbers differ by a common number, that is 2. So this is an AP. Now what does an plus 1 means? What does an plus 1 means? You very clearly know from here is what is the common difference? What is the common difference? It is 2. Let us take n equals to 5. So what is an plus 1? This is a 5 plus 1. This is 6. What is the sixth term? 1, 2, 3, 4, 5, 6. What is the sixth term? That is 11. What is an? That is a5. This is how much? 9. Now D. D equals to a6. You can say an plus 1 minus an. So what is an plus 1 here? That is a6 minus a5. That is, what is it is? 2. Now, what is the basic behind it? If the difference between the successive term and the preceding term, if the difference between the successive term and the preceding terms comes a constant, see this is the constant. If the difference between the successive term and the preceding term comes a constant, then the general term of the sequence gives an AP. And if the difference doesn't come a constant, then it will not give an AP. Let us take another example where we will differentiate it very easily. The question is, show whether the sequence 12 plus 1 gives an AP or not. Listen friends, listen the very basic thing. If the given sequence, if the general term of a sequence is a linear polynomial in degree 1, if the degree of the general term of any sequence is 1, if the degree of the general term of any sequence is 1, that is the equation in one variable, then that will give an AP. And if the degree of any sequence general term, if the degree of any sequence general term is 2, 3, 4, then that will not give an AP. Remember very clearly, this is the general term. This is the general term of the sequence. What is the general term of the sequence? That is 2n plus 1. The general term of the sequence is 2n plus 1. This is a linear equation in one variable whose degree is 1. So very clearly, directly you can say that this will give an AP. very clearly. But if the degree of the sequence of any if the degree of the general term of any sequence is 2, 3 or 4, straight away say that this will not give an AP. But how to solve it? Now let us look. an equals to 2n plus 1. Let us find out an plus 1. So in the place of n we put n plus 1. So it is 2n plus 1 plus 1. So what it is? 2n plus 2 plus 1. Altogether it is 2n plus 3. Next, an plus 1 minus an. How much it is coming? 2n plus 3 minus 2n plus 1. So it is 2n plus 3 minus 2n minus 1. 2n 2n get cancelled, it's 2. So if the difference between the successive term and the preceding term comes a constant, see this number 2, this is a constant and that is independent of n. It has no n here, nothing. If the difference between these terms, if this difference comes a constant, see this 2 is a constant that is independent of n, then this sequence gives an AP. And this is the common difference. This is the common difference. Since an plus 1 minus an plus 1 should be written downwards, is independent of n. Therefore, an equals to 2n plus 1 gives an AP. See, directly from here we can say that since this is a linear equation, it will give an AP. But how will you show it? So this is the method how to show it. This is how you will be showing it. Okay, let us take another example. The next question is, show whether the sequence 2n square plus 1 gives an AP or not. This is what you have to show. Show whether the sequence 2n square plus 1 gives an AP or not. So start with this. An equals to 2n square plus 1. You directly look here, 2n square plus 1. This is a quadratic equation. What is the degree of this general term of the sequence? What is the degree general term sequence? What is the general term degree? This is 2. So if the degree of the general term is 2, this is quadratic. You can directly say that this will not give an AP. But how to solve it? Let us find an plus 1. So in place of n, we will write n plus 1. N plus 1 whole square plus 1. This is 2. N square plus 2n plus 1 plus 1. 2n square plus 4n plus 2 plus 1. This is 2n square plus 4n plus 3. Next you find an plus 1 minus an. So this is equal to 2n square plus 4n plus 3 minus 2n square plus 1. This is 2n square plus 4n plus 3 minus 2n square minus 1. 2n square gets cancelled. This is 4n plus 2. When you look at the difference of when you look at this difference, an plus 1 minus an, it comes a term which consists of n. It comes a term which consists of n. So since the difference of the successive and the preceding term is dependent on n, since this term is dependent on n, then the sequence which is demonstrated by 2n square plus 1 will not give an AP. Since an plus 1 minus an is dependent on n. Therefore, an equals to 2n square plus 1 will not give an AP. So this is how you have to do it. This is how you will show what is the difference between a sequence and an AP. This is how you will show whether a given general term of any sequence gives an AP or not, and if it gives an AP, what is the common difference? The difference between these two is the common difference, and if this difference is a constant, then that will give an AP, and if this difference is not a constant, this is number that is dependent on n, then this will not give an AP. Thank you.